of non-dairy probiotic drinks from legume milk enriched with prebiotics. As I'm not able to move my, okay. So as Eli Metchnikoff, the father of probiotics, suggested that the majority of diseases begin in the digestive tract when good bacteria are no more able to control the bad bacteria. So this is an attempt to make a drink which is high on probiotics and also very high on prebiotics so that we can take care of our gut health. As we all know that we are looking forward for milk alternatives, we are looking for functional foods which are fortified and enhanced owing to the increased incidences of lactose intolerance, people concerned for their calorie consumption, weight issues, cardiovascular diseases, and fad lifestyles, which everyone is following, like flexitarian or macrobiotic or uh, vegan diet lifestyles. So we need to have such kind of functional foods readily available, and these alternatives can be cereal-based milks, legume-based milks, nut-based, seed-based. So ultimately, we are looking for something which is non-dairy and a symbiotic food. They have a lot of health benefits, as we all know, that they are antipathogenic, hypercholesterolemic, weight management can also be done, immunomodulation, anti-diabetic. So the only solution is to have a concoction of drinks which are a combination of both, which we usually call them as symbiotics. So all these drinks, the main concern here was to have a drink which is organoleptically acceptable, nutritionally rich, having low fat content, high in protein, and also cost effective. This comes to the significance of the study. So the major objects of the study was to first extract legumes milk from chickpea and cowpea by different processing methods. So whichever processing method suits us organoleptically, when we are talking about the beanie flavor, that has been chosen to be converted into a probiotic by using the set category of probiotic bacterium, and then enriched with prebiotics, evaluation of their organoleptic characteristics, and then the analysis of physicochemical, nutritional, microbial, antioxidant, probiotic properties was done. Finally, aseptic bottling, development of a food label according to FSSAI standards of India, and ascertaining the shelf life and cost analysis of the highly acceptable drinks was done. This is the research design, where the first phase consisted of extracting the legume milk and via different methods like soaking, blanching and soaking and then blanching and germination. So whichever milk came out to be the most acceptable by a trained panel, we used that milk for the further development of a probiotic drink. And we don't want to waste anything. Whatever we got out of the extraction of milk, the infiltrate, we also used to develop some recipes. The second phase consisted of ascertaining it to be a probiotic drink, and addition of the probiotic bacterium, which was done in mono and co-cultures, was done. And finally, the organoleptic evaluation of the drinks was also done. The third phase consisted of identification of the most acceptable probiotic extract and addition of a stabilizer. Herein, we used pectin, and also sugar was added to enhance the flavor of the drinks. And they were then added with 3 sets of prebiotics, raw banana powder and almond powder in one drink, and chicory root powder in the other. All these drinks were organoleptically tested on 2 scales. First, semi-trained panel was used, and then consumer acceptability was also seen as regarded to the Rajasthan's market. Whatever drink came out to be the most acceptable drink, its quality analysis were done on all these parameters. And as we are talking about probiotic drinks, any drink cannot be successful if it cannot sustain the acid and bile resistance. So a simulated atmosphere was created, and these drinks were tested on that. Finally, food label was developed, its aseptic bottling was done, shelf life and cost analysis of the packaged drinks was carried out. This is a flow chart of the whole research design. As far as the extraction of milk was concerned, it has been seen that the processing method of using soaking and blanching for both the legumes secured the highest points, and Therefore, this milk was used to be converted into a probiotic extract. So whatever infiltrate we got after the extraction of milk, those infiltrate were used to make hummus from the chickpea infiltrate, and Nigerian akara was made out of the film filtrate of cowpea. And this is a depiction, and these were also found to be acceptable by the panelists. And why we have done that? Because these are rich in fiber and we want to use it into recipes, don't want to throw it. Second phase began where we checked out the antagonistic effect of selected probiotic strains. Three strains were selected here: Casei, Acidophilus, and Bifidobacterium bifida. These were used as monoculture and also in co-cultures, and their colonies were counted for culturing the milks. The total count was calculated and it has been maintained to 10 to the power of 8 CFUs per ml of the drink. Five variations were developed by using Acidophilus, Lactobacillus casei, Bifidobacterium bifidum in monocultures, and casei and bifidum in co-culture, Acidophilus and casei in co-culture. As far as the chickpea extract was concerned, the strain of Lactobacillus casei was found to be most acceptable, and in case of cowpea, the strain combination of Acidophilus and casei was found to be most acceptable. These strains were then homogenized and added with prebiotics. Sugar was added, and then pectin was added to make it a stable drink. So here, as far as raw banana powder and almond powder is concerned, the raw banana powder was added into the percentages of 3, 6, and 9%, and almond powder was kept constant at 5%. So it has been seen that the drinks which have been added with 6% of raw banana powder and almond powder was found to be most acceptable by the panel members. Similarly, but when we are talking about chicory root powder, because of its bitter taste and beanie flavor added in together, only 3% variation was found to be most acceptable by the panel members, semi-trained and trained panel members. And also when we see to the consumer acceptability, the same results we got. Consumer acceptability and market potential was also seen, where the consumers from all the age groups were included into the study. Only the subjects below the age of 10 years was not included. Males and females were also there. And all the variations have shown the similar results as we get into our sensory lab, because we wanted to see whether the cost which we are getting are acceptable or not, because the drink which comes in the market is of the rate of rupees 12 INR, if I'm talking about. It comes in just rupees 12. So here we wanted to see that how much our consumers are ready to spend. So it has been seen that even if the drink is at the rate of 25 rupees per unit, they are quite willing to even purchase the drink and also willing to recommend such kind of drinks to others. So they have also been asked questions regarding the frequency of purchase and the novelty of the symbiotic drinks, and the results came out to be that people found it a very great idea and also found out that they are able to buy this drink on a daily basis as well. Their overall acceptability scores have shown that they are extremely happy with the experience of the drink. Finally, we came to the to 4 drinks. The first one from chickpea, 2 from chickpea and 2 from cowpea, having raw banana powder and almond powder combination, and having chicory root powder alone in it. So their physicochemical, nutritional, and antioxidant and probiotic properties was seen here. And it has been seen that pH is quite acidic. It is at the range of 4.78 to 4.37. Acidity was also quite acceptable. Peroxide value owing to the almond flour which has been used here. The nutritional composition here shows that the fat content is quite low, fiber content is moderate, and protein content is comparatively high to the drinks which are already available in the market. The total plate count ranges between log 10, log 8, 8.49 to 8.61 log 10 CFU per ml. And we have also experimented on the total antioxidant capacity on the drink owing to the chicory root powder and raw banana powder combinations. Finally, we came to the tolerance of these isolated lab strains to the gastric juices and pancreatic juices. And as we can see in this slide, that their survivability is quite high, 95% to 84%. The survivability was there in both the simulated environments. These are the labels which were developed according to the FSSAI 2011 and 2020 norms. And these are the packaged bottles. Once the bottles were packaged, we have seen the shelf life for a period of 60 days. And these are the results. Where we see, I will come to the conclusion only, where we will see that these drinks are readily acceptable till the shelf life of 40 days. And the rate came out to be 17 rupees, where the almond powder was used owing to the higher rate of almond powder. And as far as chicory root is concerned, the bottle came out to be rupees 9 and the packaging size was 50 ml per bottle. This is the overall graphical conclusion of the study, where you can see that how we came out to the final 4 drinks. All these drinks, to conclude, I can say that they are organoleptically acceptable. Their pro and prebiotic potentials are quite high. They have good physical, chemical, and nutritional properties, aseptic packaging. The labeling was quite attractive, and consumers were very happy to have this drink. The shelf life of 40 days under refrigerated conditions and quite cost effective. It has a huge market potential because as far such kind of drinks which are made out of legumes and is a symbiotic are not available in the market. Even when we are talking about the byproducts, after extracting the legume milk, they can be utilized very easily to develop fiber-rich recipes. It has a huge potential for commercialization. Even for policymakers in India, where the incidence of undernutrition are quite high, we can ask to distribute such kind of drinks into the government schools or those who are taking care of midday meal programs. And if we are preparing such kind of drinks on larger scales, the cost can be reduced highly. Even the byproducts can be used to make ready-to-eat value-added products. And on the basis of prolonging the utilization of chain of resources, we can say that these kind of drinks are highly profitable, environmental friendly. And also after the fertilization, that is one study which we are still undergoing, that fermentation of, as we call akara, which is the byproduct we get from soya milk extraction. So here this can also be used as a biofertilizer after the fermentation of the byproduct which we get. So besides these, other pulses and legumes can also be explored upon. Other bacterial strains can be used. Other flavors can be tested, which can be a future scope for investigation. And agro-food waste for developing pro and symbiotic foods can also be researched upon. We can talk about formulation of instant powders of non-dairy symbiotic beverage should be having better shelf life. Because we are not able to give high treatment, heat treatment to such kind of drinks. So we can see that how we can prevent such drinks to have for heat stable biogenic metabolites. Interventional study, we are still undergoing that study, and we need to check the pan-India market potential of such drinks. So we have filed a patent. I hope we are going to get this in this year, and a copyright for both the recipes has been done with the Indian government. Thank you so much for your patient hearing, and that's all from my side.